Okay, hello guys. So today we're going to look at the PDR and I'm going to look at all the wonderful things and terrible things that we did today. I have an external monitor, so I'm going to be looking on the side every now and then, or most of the time. So here's our title slide and our audience for this PDR, preliminary design review. As you've been looking and watching the videos we had before, we've had some Boeing engineers in the audience, and I'll show you what they told us and what kind of feedback they gave us a little bit later. So we started typically with a presentation overview. Here's a high-level outline, and we're going to start with the introduction and a background. So we discussed that we started in spring 2014. We were founded by two electrical engineering underclassmen, or two EEs for short. We talked about our goal of our organization, University of Hawaii Drone Technologies. We wanted to have students design, fabricate, and fly these unmanned drones. And then we're also part of something called VIP, the Vertically Integrated Project. It's a worldwide consortium. You combine and integrate students from freshman to senior years, and then you try to keep that student from freshman year, sophomore, junior, senior, so they increase the maturity and knowledge in that project. So we discussed after that our team organization. We talked about this at the project proposal, pretty much the same thing. So I'm going to skip this slide. We talked about how we're going to take a systems engineering perspective. You start with the high level mission statement, you go into mission requirements, and then system requirements, and then more specifics in the subsystem requirements. So you start really broad, and then as you go down different levels, you get more specific. So we said this is our mission statement. You can go ahead and read it. Okay, and then after we did that, we gave an overview of our competition. So we talked about it's a system, a small UAS competition, so unmanned aerial systems. So technically, we usually have a lowercase s, so the small s indicates small, but it's okay. So we mentioned that you're going to be using system engineering principles, and you need to have an autonomous drone to do all this stuff. This is a college level competition, and then you can have different kinds of UAS. You got fixed wing, rotor wing, and then multi-copters. And then there's a whole bunch of other organizations that will be participating and judging the competition. So there are different things that we had to do beforehand. Or as part of the competition, you have a journal paper. This is not a classic journal paper that you have to write something, you get peer reviewed, and then you get feedback. You have to make corrections or edits, and you resubmit if there are any corrections. You get accepted for publication. That's not the same thing here. What this is saying you need to write a report about all the things that your drone is going to be doing, the tests you ran, how you know it's going to be safe, your plans for a different part of the task you want to do, those kind of things. So it's a little bit confusing when they said journal paper, but I think they changed the name to like technical design paper or something over the years. Anyway, the next thing you have to do is a proof of flight video. So this video, you record your drone doing all the tasks that you plan to do at competition. Very straightforward. Then when you're in person at the competition, you give an oral presentation to the judges about what you're going to do. So some other things. So here's the fancy picture that we should have put in for the project proposal. So the red line here is the perimeter. It's the no-fly zone, so you cannot fly outside that. You have to stay inside. It's kind of like an imaginary fence, if you will. They also call it a geofence. It's not a physical thing, but it's like a thing where you cannot fly outside this boundary, and you can pre-program that boundary ahead of time. And so at the time, this was in Maryland, and this was in 2016. So the timeline, you have 10 minutes to transport all your drones and equipment to flight line. You've got a total of 20 minutes to set up, which is very generous. And you fly for 30 minutes. Do have 15 minutes for post-processing, and then for cleaning up, you have 10 minutes. So there are two main tasks, and you have to do these first, and you have to show that they're going to be done in your proof of flight video. This slide in particular, as I look at this in hindsight, this is pretty terrible. We should have put more pictures, filled the white space, and say what we wanted to do for those primary mission tasks. And so we talked about score next. This again is also a pretty terrible slide. At the time, we should have added more things like a picture, give an example, like what does objective threshold incomplete mean? Like, yes, we can see the percentages, but what are the specific metrics and give some example for that. And then we talked about Autonomous flight tasks, we break this down what that means. This is straight off the rule book. We also looked at things like the search air task, so this is the other primary task. Again, I think for these two, what we could have done is right on here, slide 12, we just put like a high level picture, a block diagram or something to explain this is what the task is about, what do we expect to do, and then it would make sense when you start getting to the scoring and all the metrics. So in hindsight, that would be the preferred method. I would say generally it's best to have like a picture that explains what you want to do and then get into more of the words and technical details and break it down with tables and things like that. So we talked about that. We talked about secondary mission tasks. At the time, we didn't do any of these things, so I don't think we talk about it here. We just briefly mention what they are, and then we just say the primary tasks are worth most of the competition point, 60%, and then all those other ones are only 40%. And then we looked at, I think this is a duplicate slide. 18, 19 are pretty much the same thing. I think 18 was an accident or something. So obviously the primary tasks are more important because it's weighted more. And at the time when we competed, all we did were these two, autonomous flight and then the search area. And those are the ones that we broke down in these tables over here. So I guess maybe I could quickly explain what this is. Maybe I'll just draw a picture for you guys so you can see what this means. So what I should have done, or what we should have done as a team, is just explain what this is. So you have your no-fly zone. Let's say it was that box, something like that. And let me just remove a few things. Let's get rid of the fill. Okay, so imagine this is your no-fly zone. You have to stay inside the box there. And then you would be given different things you need to fly at. So let's say you need to start it here, say point A. Let me make this darker font so you can see it better. And then you go to the next one, say B, and then let's make one more. There's obviously more points, but just for simplicity, let's say you have to do those three. Okay, and then what you have to do is you have to go to each of these in order. So I'm going to just connect them like this. And let's make the line darker so it's easier to see. Okay, so you have to go to A, to B, and then from B, you would go to C. So then that's kind of what this was about. And so this task is called autonomous flight task, or it's also called waypoint navigation. Don't worry, I'll change the font so you can read it. And I have a typo using an M. Okay, and I will scoot this up for you so you can read it. Vertical alignment, top, and let's move waypoint C down so you can see better. And I'll move that. So that's what the autonomous flight task is. Okay, it's a simple picture. It really tells you what to expect, what's going on. Not a big deal, not a big problem. Okay, so then after you do that, we mentioned the search error task. So this one, let me draw another picture. You've got another box to look at. And here you've got random targets throughout the area. And so we do like a lawnmower pattern. It'd be kind of hard to draw. So let's see what we can quickly do here. Let's do all right, we'll just do it this way. Okay, so if you had to cover this area looking for different targets, you would do something. It's not going to work out very well. You know what? Let me just do this. Let's do just a regular arrow. Okay, and make this black. And then you have another arrow. So I'm not going to draw the entire thing, but you guys get the point. So you would go in like this sort of fashion. And then this would repeat over there, and so on and so forth. And at the time, you're looking at this big area, so there could be a different shape on the bottom on the ground. So this might be something like a trapezoid that you need to take a picture of. And then there could be something like, let's go with the triangle. Say there's a triangle over there. And they're different colors too. So let's say this one is green, and you got a green triangle. Let's say you had like a red trapezoid. Oops. Okay, so things like that. So you're taking pictures with the camera pointed down, and you want to find these shapes. And each of these shapes has a letter on it. So say like A, B, C, or whatever. Okay, so that's basically like what the two main tasks are: competition. This is the search area task. Okay, and let me scoop this up so you could see. Okay, so you see quickly, right? In two pictures, you can understand from a very high level what the two primary tasks are. So there's some easy, quick things that we should have done. So now that you understand what we kind of want to do, let me continue. We were on, I think this slide. Yeah. Wait, this is kind of the same thing. Oh, this is just saying here in this pie chart that autonomous flight task, that's this one on the left, and the search area task, the one on the right that we just drew the pictures of, they are both equally weighted at 50% each inside of the primary task. Then see, so here we just break it down into all the different percentages for each of the tasks. And then after that, we talk about mission and system requirements. So we say we need to meet all the rules. Obviously, you want to meet the primary threshold requirements. So threshold, again, for context, this is the one in the middle here, this column, the second column. And threshold is 50%. So this is sort of like saying you pass, but you don't get an A. And then let me go back down. Oops, too far. Then we should also do the primary threshold requirements for the searcher test and autonomous flight test. So again, that's the middle column of these two slides. So we need to meet all these different things. Okay, I'm not going to explain what that is. You can pause the video, read later if you want. Then after we do that, we talked about the top 10 teams that went to competition last year and how they did. So there's an international, I mean, this is an international team. I mean, this is an international competition. So there's nations from around the world that compete. And then we talked about system requirements. So here we mention now our different, where did I put it? Yeah, we put in our different subsystems. So the ground station, there's a communication group, there's an image processing guys, we have flight control people, we have the actual hardware in the aircraft. And so each of these subsystems, aircraft, the flight control or electronics, you got image processing, ground station folks, electronics, for your communications. 5 and 2 are related. Both you need both for these. I mean, both of these use electronics. And then each of these subsystems will need to work together so that we can finish our autonomous and search air flight tests. Okay, then after that, then we break it down to subsystems. So we talk about the aircraft requirements. Again, you can pause and read it. I'm not going to explain all of it. We talked about the different trade-offs between the fixed wing aircraft, like an airplane, and then a rotary wing. We noticed that from the previous year in 2015, 9 of the top 10 teams used a fixed wing because you can fly faster, you can cover more area because again, you only have so much time to complete all these tasks in this very big area. I don't think we explained how big the area actually is during the presentation, which is a big bummer. Something we could have easily mentioned. And then we talked about, okay, which one do we want to pick? So we were shopping online, like responsible engineering students, and we like this drone called the Penguin V2. And there's like, I don't know if it's available online anymore, but at the time it was. And so then we get to this slide. So if you remember the decision-making matrix, you might notice that, hey, this looks kind of familiar. So if you watch the other videos, we mentioned before, we had this decision-making matrix. And so we went through all the different slides. I'm not going to repeat it now. Okay, you can go back and watch that video. But you notice that I tried to color code these different things. So I presented this slide. And it was really painful because if you look here, this row here, payload, weighed at 10%. And the Penguin, the one that we wanted to go with on the previous slide, to start in the case that that's their choice, it has a very small payload capacity of less than 2 pounds. So it's not very good. And the other one here to the right, the Anaconda, has a much higher payload capacity of about 9 pounds. So we ran some comparative things and we said that the overall score is 85. Now, looking at this, it's kind of confusing. So like each one of these gets its own score. This is a not a very good DMM, but at the time when I was putting this together, I thought it was good, but this doesn't make a lot of sense to me. Um, Even now when I look at it again, it's kind of confusing. So what I should have done is the classic one that I've been talking about last time. Let me show where did I put it? I put on the slide. So we talked about criteria weights on this one. This is the piecewise component chart. So we should have used everything I mentioned in this slide deck to feed into our decision-making matrix to pick which one of these drones is the best. Come up with our percentages and then determine, okay, objectively, what is going to be good to use or not. Material kind of isn't a really good factor here because we don't know what the 3DR Aero M and the custom built material is, and like why is foam considered green or good? That's not very clear. The time for assembly and shipping, I mean, yeah, it takes a while. So time is a consideration, but just purely design factors, in hindsight, wouldn't look at those two things. The cost, the payload capacity, electronics, that matters a lot more. By flight controller, we mean like, does it come with a brain that can do the autonomous functions? So this one, I think the answer was it already comes with it. And I remember putting this line in short story when we got here, we said that the Penguin was the best, and we said because that's the one we chose. We got some questions from the Boeing engineers, and they're like, "So, Evan, why did you pick this one if it has a small payload capacity?" So I don't remember what I said. I gave some answer, and then it just kind of snowballed into this long, terrible discussion. And I talked to my professor afterwards when we looked at this decision-making matrix. Well, not really, but my attempt to make a good one. And he told me that, Evan, you should have just said early on that we didn't really consider the payload a whole lot. Yes, it's in our matrix. Yes, we understand that it's one of our factors in making our decision, but it wasn't weighed high enough and we didn't look at it carefully enough. And so if we did that, then clearly, yes, the Anaconda was the better choice. And later on, our Boeing engineers in the audience, they actually mentioned to us that maybe if you have the funds, if this costs more, is it worth it just buy that kit? It's a very good question. So that all could have been alleviated if I was just a little bit more transparent about our process of picking the payload percentages and that we really didn't consider payload a whole lot, even though this should have been weighed more. And that would have deferred our analysis a little bit to picking the Anaconda at the time, most likely. Okay, now let's go to the next slide. So we talked about some specs about this Penguin. Okay, we also talked about the foam, APO, expanded polyolefin APO. And this is just going to satisfy some requirements. As a side note, for the future, I would have wanted to see how this specific spec satisfies a very specific requirement in the rulebook. So citing it or putting it here on the slide would be super helpful. We talked about lift, but the Boeing guys know all about it, so this was sort of not appropriate. We talked about the fuselage, the location of it in terms of the CG location. We talked about the payload. So here we didn't include things like wires. This was a lot of the high level components. And then we also talked about the current status, like do we have funds for this? Is it going to be ready to fly yet? And we needed to find a drag coefficient. Then we talked about drag. We talked about, after that, some aircraft risk mitigation plans. We talked about the material performance of the different types of material you could use to build a drone. This slide in particular felt kind of out of place when we presented it. And also, it also seems kind of unusual to put in here because if we buy Let me go back. If we bought this penguin, which is made out of foam, then it's kind of like, then why do you need to present slide about material performance if it clearly has foam? I mean, yes, it performs pretty nicely, but carbon fiber and balsa wood performed better. It had a bigger number. So this slide's kind of a little misleading, but we'd presented it anyways. We'd look at types of wings. Okay, I'm not going to go into all the details. We looked at analysis of different designs. So these are useful information, but what's kind of dumb is that the Penguin already has a particular design. So it's like even if we found a good design, but if the Penguin doesn't have it, then what's the point of having this analysis, right? So it's a little bit silly, but I forget the reason we included that. Okay, and we did the same for the empennage. But here, what we should have done is mention how all these different types of wings, the analysis of designs, and then the design analysis of empennage go back to the penguin. What kind of wings, empennage, design analysis the penguin had? And is it true that it has all these different criteria? The score is going to be high for the design choice and things like that. But I don't think we mentioned that, so that's kind of a big bummers. Okay, and after that, we went to the image processing system. So they're responsible of finding all the targets. When we're in that search area, they got the camera pointed down, taking pictures. And so we needed to take pictures and then crop out the target and then send it to the judges. Okay, so here's the flow chart. You would take a picture. If it's QR code, great, and you found it. But if it's not a QR code, you need to identify characteristics. We had two different algorithms for that. We also need to get the GPS coordinates of the image that we took. Okay, so we should have put a picture here about like the camera's pointed down at like what angle and also like how high we're flying, things like that. Here we mentioned that we're going to go with this camera. There's a lot of green here, but there's no score, so this is not a classic DMM, right? So we don't know what the totals are, we don't know what the scores are. We also don't know what are the weights for all these different categories and criteria on the left. Because maybe the appear or mapper visible light is also good because we've got a lot of green here too. So it's not clear, but for whatever reason, we went with this one. So the software we use is QGIS, and we should have put pictures here, explain more what this is. This slide here, we go into the implementation of what this is going to be doing. When you find something that's you're interested in like the shape of the target on the ground, and you can use the georeference function that gives your GPS coordinates, and you need to tell the judges the coordinates for that target. So here I think we're trying to explain like, okay, if you're at this grid location, then the target's here or something. So we went to some advantages, disadvantages. We talked about future work or image processing. Again, this slide's got a lot of white space. We should have filled it out, put more examples or pictures or diagrams or something. And we went to the flight control system. So here's the requirements. We had some block diagrams there about how the electronics are involved. And then we used the PICSOC as our flight controller. This is the brain that does all the autonomy. So that's the keyword there, autonomous capable. And it's got gyroscopes, got accelerometers on it. And then we mentioned other things. We talked about different battery options. So again, this is not really a good DMM. We don't know the scores. We don't know the criteria, percentages. We don't know that's a clear winner other than this one has the most green. Okay, but it's a little bit odd. Um, because this one's got 3 green, the ready-made RC. But does most green mean it's good? I mean, the Zippy also has 3 too, right? 3 green. So it's not a very good DMM looking back at hindsight. We looked at electronic speed controllers. We had these different ones here. So again, there's no cost, no total cost or the scores, and we don't have the percentages for the criteria. So again, it's not a good DMM. And then how do we know what red, yellow, and green mean? So there's no relative weighting, the other secret that I mentioned in the other video. We looked at brushless motors, same thing. Not a very good DMM. We did a battery test, see how long it's gonna last, I guess. And we looked at the ground station communication system. We had to display the aircraft's position, that no-fly zone, that red boundary I showed on one of the pictures earlier. And then you need to send in data to the network on the ground. Okay, then we talked about ground station software. There's two, there's APM Planner, there's Mission Planner. We ended up going with Mission Planner. We still use one today. And then we talked about different frequencies we operate on. We talked about the hardware involved in that. We talked about how the network works when you transfer data down. And then we talked about the formula targets. This should have been mentioned in the image processing slide somewhere earlier, but for whatever reason, we put it down here. And we talked about safety regulations, so like who's our safety pilots, talked about how the ground control system, people need to be safe when you're going to be working over there. So things like eye protection, hearing protection. And then for the aircraft, you need to have different flight modes, making sure that you're good to go. And I think you need to check your batteries, your fuel, and then make sure it's a bright color so it's easy to see, things like that. We talked about a physical inspection of the aircraft during competition. Make sure that you're less than 55 pounds, or else you're now going to be considered a different class of aircraft. And then you have to make sure that you've satisfied all these flight termination checks. So if you lose communication, all these different things need to happen. And after that, we went into project management. We looked at our Gantt chart. So this was made in Gantt project. In another video, I'll explain some secrets and inside tips about Gantt charts. So I'm not going to explain all the good and bad things we just did over here, maybe somewhere else. Then we talked about some risk mitigation. This risk cube here, I will make another video about that later on, how you do a good one. And then we talked about finance. We talked about a quick summary of what we've done, I mean, what we did. We were the first team to go to competition. We want to just do 2 tasks, and we're multidisciplinary. And that's yeah, that was the end of the slide deck. And then after that, we had like an appendix of backup slides in case people had questions about something more specific, things like that.